Now we're saying the risk neutral probability measure under the log normal process with a constant volatility doesn't really reflect the true market reality. In principle, by observing the market itself, we can recover a risk neutral probability measure that is implied by the market observations. And we can do that numerically. Now, this is a paper published in 1978. So essentially, the idea is that, let's say you have a call. What is a call? A call basically is the expected value of this payoff and maturity, which is the maturity time t, based on a particular probability density distribution. If we integrate that from strike and up, right? Then this will give us the call price. Now, if you take the first derivative of change of call price and change of the strike price, you basically get a condition like this. Okay, basically an integral of this probability density function here. Now, if you take the a derivative again, you actually have this condition. Now, this little g is a function of the stock price. And let's say, so basically you've got an integral here, right? And if you take the derivative over this integral here, you see that this integral is also, the integral itself is a function of k as well, because k is the starting point. So you can take a derivative of this entire thing, which includes this integral, against k again, then you get a function of k. And this function of k is really the implied probability of the realized price greater than k, because you're taking the integral from k and upward. Okay, so this is basically a implied probability distribution, and you will have this expression here, which is related to the second derivatives of the call price with respect to the strike price. Now we can use some techniques in a way. It's like a central moment here with of the finite, not central, the this is like the central difference that we have seen in lecture on the numerical procedures. So we can actually generate this distribution. So what we need is we need 3 calls. So these are the call options with different strikes. So K1 is a strike K minus some delta, and we need an option with a strike K, and we need another option with a strike of K plus delta. All 3 options, however, would need to have the same maturity. So then we can have a procedure to generate a distribution like this. So this will be the big G function, which is a function of K. So basically, that is this function here that we generated using this approach. Now, once we have this, if we see that the log normal process, the log of price will be a distribution something like this. Okay, whereas the real probability distribution here will have bigger mass to the downward movements. Now, what is the use of this? Okay, now we know this is the actual shape of the distribution rather than a really symmetric normal distribution. but the log changes. Well, we can basically price options if we recover this the quote unquote truer risk neutral probability density function here, or probability distribution function here if you're looking at the math. So you can do this because this is created numerically. You can price your option numerically based on this. And those options will be consistent with the current market move, the current observed market prices. Suppose you have those three options, the three calls that generates this, and if you want to price an option with a strike that are somewhere in between of those strike prices, you can actually use this one to numerically calculate the price of the option. And you don't, in this case, you will get a price that is not given by the Black-Scholes formula, but quote unquote will be more reflective than the current market movement than the Black-Scholes formula. So i.e., if you have the call with a strike price of 120, 180, you can then use the recovered implied density and risk neutral density function to calculate options with a strike price that are 105, 95, for example. Then you will see that once you calculate the price used from here, those prices will have different volatilities. So the price with the strike of 95 will have a different volatility in relation to a price for the strike of 100, for example, because by definition, what you have done here does not assume a constant volatility.